Hey guys, welcome back to the channel. This looks like a fun question, and we have -1 to the power of a square root of pi, and we have to figure out the value of this question. And the way we're going to solve this is that we're going to get some help from the Moore's theorem. And what this theorem says is that when we have e to the power of I theta, this will be equal to cosine of theta plus I sine of theta. If we look at this, we can see that we can write our number based on one real part and one complex part that has I, or our imaginary number, and -1, if we want to write it down, so we basically have -1 plus 0 imaginary part. And if we look at this, we'll see that it means that we have to have cosine of theta -1. So let's have a look at the cosine diagram, and if we look at it, we'll see that we'll have something like this for cosine on both x and y direction. And we'll see on these spots here, we have -1, which is what we're looking for in here. And this will be pi. Here we'll have minus pi, and so on. 3 pi, we have the same thing. So it looks like if we can write down our theta based on 2k plus 1 times pi, we're going to get all the values for theta that we're going to get cosine of theta -1. And obviously k here belongs to integers. So from all the minus numbers, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. So we're going to get some help from this, and we're going to write down our -1 in this form, which our -1 in here would be e to the power of 2k plus 1 pi. We basically have e to the power of 2k plus 1 pi all to the power of square root of pi, and this is basically what we need to figure out. So we're going to get some help from the laws of the exponent. When we have a to the power of m to the power of n, this will be equal to a to the power of m times n. So basically we can multiply these two. So let's do that. We have e to the power of 2k plus 1 times pi times square root of pi. And we know when we have a square root of something, this will be equal to a to the power of 1/2. So we have the square root of pi in the exponent. So e to the power of 2k plus 1 pi times pi to the power of 1. And now looking at here, we see that we have a to the power of m times a to the n. So this will be equal a to the power of m plus n. So these are our a, and this will be our mn. So basically this can be written as e to the power of 2k plus 1 pi 1 plus 1/2. And we know 1 plus 1/2 is 3/2. So this will be e to the power of 2k plus 1 times pi to the power of 3. We can write it down based on the Moore's theorem. So it can be written as this. So e to the power of 2k plus 1 times power of 3/2 can be written as cosine of 2k plus 1 pi to the power of 3/2 plus pi times sine of 2k plus 1 pi to the power of 3. So that's going to be the final answer. And obviously, again, our k belongs to integers. So we have infinity answers for this question. Hope it was helpful. Let me know if you guys have any other approach to solve this. And you guys take care. I'll see you in the next video. Have a good one.